All right, so we are looking at chapter 3, part 1 for our lecture for this week, looking at 3 claims and 4 validities, some of the interrogation tools for consumers of research. So, what we will focus on for this part is looking at what are variables, what are the 3 different claims, and kind of talking about some of those components. So if we start with variables and constants, and this is where we start to really get into some of the kind of heart of the content of this course, a variable is something that can vary, right? It's an element, feature, or factor that is liable to vary or change. It can be literally anything. A few quick examples I can be found in this little image to the right that I included, but you could think of anything. It could be the weather, it could be the time of day, your grade point average, how many pieces of cake you eat in a single day, the number of hours you spend watching TikTok. I mean, it could literally be anything. So on this example list that I have for you, you can take a look at variable list 1. You can look at intelligence, blood alcohol concentration, money per year, GPA, number of boyfriends, number of appliances owned. Literally a variable can be absolutely anything. And when we are examining a variable, it must have at least 2 levels to it. Now, it can have quite a few more than that, but it must have at least 2. So maybe how are we defining that variable, which is something that we'll get into quite a bit more in a little bit. A constant is something that can vary, but only has one value in a study. So we're holding it constant or steady. We're giving it only one value so that we can very easily make a direct comparison. And in research, each variable can either be measured or manipulated, which again, we'll talk quite a bit more about in just a moment. A measured variable is a variable where the values are observed and noted. Incredible number of examples of this. It could be IQ, sex, blood pressure, and so on and on and on. This is something that we observe and record. A manipulated variable is something that the researcher is going to exert influence on, usually by assigning subjects to different conditions. So with one of these, we're just measuring. We're not changing anything. We're observing and recording what we have found. With a manipulated variable, we're actually deliberately exerting influence or deliberately manipulating people to different conditions or different groups so that we can see what the outcome will be. Another way of thinking about that is we're trying to control it. And if you look at these two a little bit, some variables can only be measured. In some cases, things are naturally occurring, or maybe it's unethical for us to try and control or manipulate it in some way. And some variables you could either manipulate or measure depending on the design of the research, depending on your goal and what you're trying to accomplish, and maybe also depending on your resources and money and time and so on. So we can have things that are measured or manipulated, and those tend to be different items, which we'll see when we get to the different claims and types of conclusions that we're trying to make. So whenever we're trying to look at our variables, it's very important to give them definitions, to define them clearly and make sure that we have a clear understanding of what it is that we're trying to do. And so we oftentimes start when we're trying to conduct research, we start with a conceptual variable. Another way of thinking about this is more of a construct. So something like happiness in relationships or time spent socializing. It's something that tends to be very kind of vague. Another example could be school achievement. So we start with this big idea, right? Kind of a vague construct or an abstract construct. And then we have to operationalize or operationally define what that construct will be measured by. So we're going to turn that construct or concept into something that we can measure or manipulate. So let's say that we want to know about school achievement. Our conceptual variable, our abstract concept would be school achievement. And then we could operationally define that by do you get A's, mostly A's and B's, mostly B's and C's, Asian bees. I love that. Again, the captions won't always be perfect. That's amazing. So we can look at the specific grades that you're getting and use those grades as a way to define school achievement. We could also operationalize it to be your GPA if we wanted to go that route instead. So taking something kind of big and abstract and turning it into a very concrete, defined, measurable, or manipulated variable that we can then go out and study and draw conclusions from. Now, we have a couple of different types of claims that we can make as well. And all of these things that we're talking about in this chapter will be built on and come back many times over the rest of the semester. But a claim is basically an argument that somebody is trying to make. You claim that something is true, or you claim that something is present. It's an argument or an assertion that you're making about something in the environment. And not all claims are based on research. It's very easy to make a personal claim that you believe to be true, but we're trying to embrace the scientific research mentality in this course. So 3 main types of claims that we tend to have. The first are frequency claims. The second are association claims. And the third are causal claims. So I have some examples over here. A frequency claim, 1 in 25 US teens attempt suicide. An association claim, mixed weight couples argue more. And causal claims, music lessons enhance IQ. So a couple of examples, and this is something that's talked about really nicely in your textbook as well. But let's look at them a little bit closer. A frequency claim describes a particular rate or a degree of a single variable. 72% of the world smiled yesterday. 51% said they learned something interesting yesterday. On average, 130 Americans die every day from an opioid overdose. So with frequency claims, they're going to contain a number, 72%, 1 of 10, 130 Americans, right? We're looking at some kind of frequency or how often something is happening with a single variable. They only involve one measured variable. We have measured how many people get COVID in one day, or how many people smile in one day. And then we're going to make a frequency claim with that information. An association claim, which we sometimes can call a correlation, which we'll talk more about later as well, is when we look at one level of a variable likely to be associated or correlated with a particular level of another variable. So here we have at least 2 measured variables. And we can talk about how intelligence is usually associated with GPA. Another word for that would be correlated. Intelligence and GPA are often correlated with each other or associated with each other. The stronger the association between 2 variables, the more accurate the prediction we can make will be. So we could say if there's a very strong correlation between intelligence and GPA, we could predict that somebody who has high GPA is likely to be intelligent. There's also a high correlation between sleep and functioning, right? How many hours of sleep people get tends to determine how well they function and their mood the following day. So whenever we're using an association claim, we could talk about how strongly related 2 things are to each other by using a couple of different metrics. We can use a number that we call Pearson's R, or we can use a scatter plot, which is typically just a graph with a bunch of dots that are plotted out to give us an indication of how strong a relationship might be. Now, these associations between variables can be positive, negative, or 0. A positive and negative association can help us make a prediction. That means there is a connection there. But if there's a 0 association, that means that 2 items are not associated with each other at all. And let's look at what these would look like. If we examine a scatter plot, we can see the positive, negative, and zero correlations kind of laid out in front of us. And this is a very easy way to look at how associated or correlated two items are with each other. The other one being Pearson's R. So if we want to look at a positive correlation or a positive association, on this axis here, we have relationship longevity, how long a relationship is lasting. And down here, we have the amount of expressed gratitude. So our conclusion here, or kind of takeaway, romantic partners who express gratitude are more likely to stay together, or stay together longer might be more accurate. And this is a positive association. And this, what we're looking at here, is an example of a scatter plot. We have one variable on the x-axis and one on the y-axis. And each one of these little dots represents a participant that we've measured, some data that we have gathered. So if you look at these dots, if you were to draw a line to represent the slope of these dots, and we won't do that math because math is not our focus, right? We're looking at statistics, but not math, very important distinction. But if you were to look at these lines, they kind of cluster in a direction that goes upward. Positive associations have that kind of upward slope. And what a positive association means is that both variables move in the same direction. As gratitude goes up, so does relationship longevity. As the number of slices of cake I eat goes up, so does my weight, right? True, sadly, cake facts, right? But positive association means that two things or two variables move in the same direction. As one increases, so does the other. A negative association means that two variables move in opposite directions. We sometimes call this an inverse relationship. As one variable goes up, the other one goes down. And so we could say, let's have an example here. We can go with the one on here. Here we have the frequency of multitasking with skill at multitasking, right? So people who multitask the most are the worst at it, could be our conclusion. As people multitask more, their skill at it goes down, right? So with negative association, the graph goes the other way, kind of an inverse or negative relationship that two things move in the opposite direction. The more I exercise and watch what I eat, the less I weigh, right? My weight goes down. They move in opposite directions of each other. Unless I eat cake, and then that nullifies the entire effect of my exercising. True story, true story. A zero association means that two things are just not related to each other. They're not associated, they're not correlated. Very rarely is something completely zero, but it can be very close to zero. So if we look at this, on this axis, we have time of dinner and childhood weight. A late dinner is not linked to childhood obesity, study shows. So you could see with these, the plot data, these little data points, all these participants, it's kind of all over the place. If we were to draw a line to represent the slope of this, it would be relatively flat, indicating that there is no or little relationship between these two variables, what we would call a zero association. The tricky thing about correlation and about association claims is that just because two things are connected to each other does not mean that they cause each other. So there can always be other factors at play. The relationship might move in the opposite direction. There's a couple of issues that can lead us to a very important phrase, and that is correlation does not equal or imply causation. This is a very important statistical and research principle that just because two things are correlated with each other does not mean that they cause each other. When we're talking about association claims, we're talking about a naturally occurring relationship. We haven't manipulated anything. We are simply just measuring naturally existing variables. So correlation does not equal or imply causation. A very important phrase to remember. It's possible and likely that there are other factors in play, which we often refer to as the third variable problem. There might be two variables, X and Y, that can be statistically correlated with each other, not because X causes Y or because Y causes X, but because some third variable z causes both x and y, right? Lots of letters for you there. So let me give you an example. And this is a very commonly used example, and I like this example as well. If you look at this graph right here, this scatter plot, we have a fairly strong positive correlation between ice cream consumption and drowning deaths. So a very easy takeaway might be for someone to think that, oh my gosh, ice cream consumption is causing drowning, when of course that's probably not the case. There are other and probably third, fourth, and fifth variables that are present. One very common third variable explanation for this is the time of year. In the summer, people are more likely to eat ice cream and they're more likely to go swimming, which means that drowning incidents also go up. So temperature or time of year could be the third variable explaining both of these things. So we always have to think of those possible third variables that could be explaining what we're seeing. There's also something called the directionality problem. The two variables can be statistically related to each other, but it could go in either direction. It could be that one causes the other, or it could be the reverse situation. So we have to look at directionality, and we also have to consider any potential third variable that might explain both of the things that we're looking at. So correlation and causation are not the same thing. Two things can be connected to each other without directly causing each other. Our last type of claim that we can make, the third one, is a causal claim. So we can't determine cause with association, but if we do a causal claim, then we are looking at one thing causing another. One of the variables is responsible for changing the other one manipulated variable and one measured variable. So for example, we could say music lessons enhance IQ, or music lessons may enhance IQ. We can use different language to get there. But if we did an experiment, rather than just looking at a correlation, experiments allow us to determine cause. They allow us to support a causal claim as long as they're done well and done correctly, things that we'll talk about later in the semester. But experiments, when you deliberately manipulate a variable, allow us to see how it affects something else. Let's manipulate the number of hours of sleep that somebody gets and see how well they perform on an exam the next day. We can then make some inferences about how sleep and sleep deprivation might affect somebody's ability to perform on an exam. So causal claims manipulate variables in order to determine cause or to support a causal claim. So if you look at this, and this is definitely in the textbook as well, in the book, they show you some language that might help you to determine the two. Association claims use phrases or words like is linked to, is associated with, is correlated with, may predict, goes with, is tied to, are more or less likely, versus causal claims, causes, affects, exacerbates, may lead to, sometimes makes, promotes, reduces, using very different language to assert these conclusions. So this is just another way that you might be able to determine the type of claim that somebody is making with their research or with their article or whatever it is that they're presenting it within. All right. So that is the lecture for chapter 3, part 1. Make sure you get going on all of the materials for this week, all the other assigned stuff, and get all of that done before the weekly deadline. I will see you all next week for our next topic.